Game on. Here we go. Express the exact value of the trig function. This is basically what we just did in Bellwork. Okay? Just given a little differently. In the example, they say tangent is 5/2 and tangent is x over y. So if tangent is x over y and it's positive, it tells you they got to be the same sign. That's something we haven't done in a while, but remind yourself of that. Cosine is less than 0, so that means x over r is negative. Things like that, and then we plug in. Let's look at the one together here, and it'll make more sense. Sine is this. It's in quadrant 3. Find cotangent. What do we start off by writing on our paper? X, Y, R. Before we do anything else, X, Y, R. We want to make sure we use all that information eventually. To start off, let's look at this part. Sine of theta is -4/5. So we're looking at our unit circle if we need it. When we talk about sine, Craig, what is sine going to be for us? Y and R. So Y is 4, R is 5. One of those two things is, are they both negative? No, if they're both negative, be positive. The Y is negative. The Y is always going to be, or the R is never negative. So I know it's the Y that's negative. Did that, cool. Do I know what my X is right now? No, I wish I did, but I don't. How do I find a missing one when I've got 2 out of the 3? Pythagorean theorem, x squared plus y squared equals r squared. This one's easy. One of them is 4, one of them is 5. What's the other one? 3. Okay, you could do Pythagorean theorem. I'm not going to. I mean, we can do it. The key to this, though, is when I finish that, it would have been x squared equals 9. And it's really not just 3, it's plus or minus 3. I need to make a decision whether it's plus or minus 3. That's where this comes into practice here. I'm in quadrant 3. If I'm in quadrant 3, what's going to be true about my x value in quadrant 3? It's negative. They're both negative in quadrant 3. So we've got our chart filled out. Once we've got this, then all I have left to do is find cotangent. If we're doing cotangent, again, we're looking at our unit circle. When I see cotangent, what is cotangent going to be in terms of letters? X over y. That's just looking at my unit circle. My x is -3. My y is -4. Don't leave it like that. -3 over -4, what's that tell us? It's positive, 3/4. Positive. That's my final answer. Yep. It's just not reducing. Simplify it. Questions on the first one? All right. That one shouldn't be too bad. Let's go to example number 2. Find the amplitude, period length, and phase shift. So again, we just did this in Bellwork. Okay, up here you got an example of me doing each of those things. Let's do it again. We just did it in Bellwork, so we shouldn't need too much. Amplitude, period length, phase shift. When we talk about amplitude, that's the stretch on our graph. Gene, what's our amplitude going to be on this one? Yep, -4. You can just say 4. It doesn't matter. What's that negative really going to do to my graph here? Yeah, it's going to flip it. It's going to do the opposite. This is a sine curve, and so sine curves would have started in the middle and gone up, but it's sine, so we would start in the middle and go down instead. It's really going to flip it. You can call it 4. You can call it -4 for amplitude. I don't care. Because it didn't ask for it. It didn't ask for it in this one. Next thing we're going to do is period length. Period length. We start with our base period length. So when we think sine, Taylor, what's our base period length on a sine graph? 2 pi again. More than likely it's 2 pi. Times the reciprocal of whatever's in front of our x. So Jamu, what's in front of my x here? 2. If I'm multiplying by the reciprocal of 2, what am I really multiplying by? 1/2. So 2 pi over 1, if you want to make it over 1, times 1/2. We are multiplying those things together. We are multiplying straight across. So what can I do? Yep, reduce 2 and 2. It's just pi. Next thing is phase shift. To talk about phase shift, we start off with horizontal shift. Phase shift is just like horizontal shift. Okay, the only difference with phase shift and horizontal shift is there is a period length change. It's not just 2 pi. That's what the difference is. So we start off with our horizontal here. Okay, that's whatever's added or subtracted in parentheses. So, Steve, what do I start off with here? What's my horizontal? That's whatever's added or subtracted in the parentheses. So I'm starting with this. And then I'm going to multiply by the reciprocal of whatever's in front of my x. So what am I going to multiply that by? 1/2. He's got this 2 still in front there. He's going to multiply by 1/2. So my answer is just straight across 3/2. But this is a phase shift, which means there needs to be some direction with it. It's either left or right. Okay, and that comes down to what sign is it? It's a minus sign. So we do the opposite. Anytime we have something in parentheses, we always do the opposite. Which way is it going to go here? Right. It's negative, so we do the opposite. It takes us to the right. 3/2 to the right. Questions on, is that 2? Okay. We're right there. Let's go to 3. Number 3, we're graphing. Cool. Just did it again. We're going to do the same thing. Okay, I don't want to go through that example. We just did one. Let's look at example A. First thing we're going to start off is list the important stuff. Amplitude, period length, horizontal shift, and vertical shift. I'll give you reminders on that on the test in terms of what you need to start with. But that's our base stuff. Okay. Aubrey, what's our amplitude going to be here? 3. What else is true about this thing? It flips. That's something you probably want to write early. It flips. Yes, I just want to always write flips on my paper or I forget. I could write a negative, but it doesn't stand out to me like writing the word flip. Period length, Jacob. What do I always start off with my period length with? 2 pi. And then I'm going to multiply by the reciprocal of whatever's in front of my x. So what am I going to multiply by? 1/2. He's got a 2 right there. So he's multiplying by the reciprocal of that. It's 1/2. When you multiply that together, what can you do? You just get pi. Good. Cancel it out and just get your pi. That's our period length. Then we're doing horizontal shift. Joe, is anything added or subtracted inside of parentheses? No, so there's no horizontal shift. There's no phase shift either. That's not even mentioned here. Last thing we're going to do is talk about vertical shift. Which way do I have a vertical shift here, Isaiah? Is something added or subtracted on the end? Yep. Which direction am I going to go? Down 2. This -2 right here, remember, vertical shifts. It's whatever it's on the end, and you do what it says. So we're going 2, and we're going down. That's correct. The last one was in parentheses. That makes it go left and right. When it's tagged on the end, not in parentheses, it goes up and down. Good question. Now we're graphing this thing. So we already made our graph. I made 2 lines. I made my 4 hash marks. Okay, the next thing I'm going to do is label my period length. So that means this one is pi. The one in the middle is going to be half of that. This one's going to be half of that, or 1/4. 1/4, 2/4. This one is 3/4. Yep. Once I've graphed the period length, the next thing I'm doing is vertical shift. So on this one, my vertical shift, Isaiah told me, was down 2. So I'm going to go down 2 to -2. And what's this going to be right here? That's my midline. That's the middle of my graph. Everything is going to go around that line. It's going to be evenly balanced around that line. Once I've done my midline, then I'm doing my amplitude. Okay, that's the stretch. How much do I need to go up and down from this midline? 3. That's my amplitude. That's my stretch. So from here, I'm going up 1, 2, 3 to +1. There's the top of my graph, and go down 1, 2, 3 to -5. That's the bottom. Those are the only 3 lines I'm touching, the top, the middle, and the bottom. Okay, don't touch that black line in the middle. Doesn't matter here in terms of my graph. This is a sine curve again. So if I'm starting a sine curve, where am I going to start? Sin in the middle. We start right there. And it's flipped. Don't forget that it's flipped. So since it's flipped, instead of going there and then going up, we're going to start there and go down next. So at this next hash mark, I'm down. At my next hash mark at pi/2, I'm in the middle. At 3 pi/4, I'm at the top again. And then at pi, I'm back to the middle, giving me this curve right here. Yes, ma'am. Cosine graph start at the top.
Yeah, like, is there something that would make it go, like, start at the bottom?
Yep. What would make a cosine graph start at the bottom? If it's flipped, if there was a negative in front, just like the sine one. So again, number 4 we already basically did in bell work again, so we shouldn't be too bad here. Given this, we're trying to find tangent. We see given information and we're trying to find a trig function. How are we starting off? X, Y, R. X, Y, R. It's an ordered pair. So this one's X. This is my X. This is my Y. That's my R. Since my bottom is the same, we can consider it my radius. R is 9. X is 2. Y is square root of 77. This one's easy. This one's an easy one. You don't have to think. You just write stuff down. In the end, we're trying to find tangent. Okay, trying to find tangent here. So to find tangent, tangent means what to us? Y over X. I wish I would have done cotangent because it would be a little bit harder. But this one's easy. Y over X is just square root of 77 all over 2. What happens if it were cotangent? It was 2 over square root of 77. You'd have to multiply top and bottom by radical 77.